welcome everyone, and thank you for being here today. We will wait a couple more seconds for almost a minute for everyone to join in today. Just as a quick reminder, this webinar is organized within the framework of the IPCEI Microelectronics and Communication Technologies program, with the goal to give you a broader view of what kind of opportunities there are within this program, and today with a specific focus on the RTOs. So I would say we wait one more minute for everyone to connect, and we are looking forward to discuss with you afterwards in the Q&A session any questions you might have with regards to this topic. Okay, I think we are now, most of us are connected, so welcome again. Thank you very much for being here today, and we're really looking forward to have all your questions in the Q&A tool of the Teams. So please don't hesitate to go in this tool and write your questions there while the speakers are talking about their topics. You can also vote on the different questions there are to mention your support for these questions and make sure that it will actually be discussed during the meeting. If by any chance we have too many questions, we will get back to them at a later stage. So my name is Mirelle Teveer. I'm program leader for the IPCEI ME CT, and it's a pleasure to welcome you to this webinar on the role of research and technology organizations, RTOs, in Europe's semiconductor ecosystem. Today, we will hear from two distinguished speakers. We are very pleased to have with us Bruno Paing, VP of Europe and International Public Affairs at CEA-Leti in France, and Lorenza Ferrario, who is head of the Micro Nano Facility at Fondazione Bruno Kessler, FBK. They will share their insights on how RTOs contribute to innovation and collaboration across Europe's microelectronics and communication technology sectors. A quick reminder again is please use the chat feature for any other remarks, and use the Q&A tool to ask your questions, which will be discussed after the presentation, and we will try to address as many of them as possible. To now begin, I'm pleased to introduce to you Bruno Paing, who will share his perspective on collaboration within European RTO landscape, and also to discuss practical steps for engaging with pilot lines and major projects. Bruno, the floor is yours.
Thank you very much. So I'm Bruno Paing, so VP Europe at CEA-Leti, and I will try and have a few words about RTOs. And I would first like to thank my colleagues from Fraunhofer and IMEC, because this is a presentation that we build within the three RTOs, and I'm talking on behalf of these three RTOs. So next slide. So first, I will try just with two slides to define what is an RTO. And the first definition I got is from the European Association of RTO, ERTO, that I will have a word about afterwards. An RTO are non-profit organization whose mission is to produce and organize research and development activities in collaboration with partners, especially public and industrial partners, and rely on very specific features that all RTOs have. You can define an RTO with an outstanding infrastructure that is a result of many years of continuous investment. Skills with building along the years a critical mass of expertise and researchers, technicians, and an innovation capability that could translate into an ability to protect the results through patents. So of course, academic lab also have infrastructure, outstanding skills, researchers, and an innovation capability, but maybe what is the difference between an RTO and an academic lab is the capability to mature technology to higher TRLs, typically from 2 to 6, to take into account also very specific dimensions like time to market, cost, development time, because the innovations that are developed by RTO need to have a path to industrialization. So we really need to take into account not only the performance of the technologies that is developed, but also some, let's say, more industrial concerns, like at what time the technology will be available, and will it be possible to manufacture this technology using the installed base. That is very important because industry needs to have a way to integrate this technology and manufacture product. It's also about, I'm sorry for the phone, it will stop. It's also a specific mindset that is developed in RTOs with a strategy that should be focused on industry expectations, and also a number of rules on organization like business model, specific contractualization, IP licensing rules that has to be compliant and accepted and compliant with industry needs. So next slide, you can see that basically, to sum up, the role of RTO is to fill the gap between academic research and what is done by industry. Really focusing on this technology development phase between TRL 3 to 6 to mature the technology and make it ready to be transferred to industry. So in the innovation process, in the next slide, you can see that RTOs, of course, work with upstream research, nurture the programs with the results from the academic labs, and work closely with universities, and then continue developing the research program to create innovative breakthrough, and then go to higher tier, mature the technology, achieve proof of concept, prototyping of the technology, and the end game is to reach the transfer, industry transfer to partners through long-term bilateral partnership. And that's important to say that usually this is successful when there is a good collaboration between RTOs and industry, and that happens in the long term. So RTOs altogether are organizing a network in Europe, and the RTO network in Europe is EARTO, the European Association of Research and Technology Organization, which is a network that has been created 25 years ago in 1999. And as you can see on the next slide, it's together today encompass more than 350 RTOs in more than 31 countries in a very large Europe. And of course, all these RTOs are not involved in semiconductor and microelectronics, but you can see that all the major research organizations involved in semiconductor technology development are there. Of course, IMEC, Fraunhofer, CEA, VTT, INL, Tyndall, I mean, all the big research players in Europe in the semiconductor field are part of this association. And the role of this association has been self-assigned on the next slide as 3 tasks. One of the first tasks is to try and organize discussion among the RTOs to define position papers and to act as research and innovation policy advisors. Second task is, of course, to provide research and innovation solution to address societal challenges, and you will find this in a couple slides presenting RTOs. Using, as I said before, multidisciplinary team, unique research infrastructure, and also a lot of partnership with different types of stakeholders. And the task 3 is, of course, to support industry. And what is important to underline is that the focus of RTOs is to support all kind of industry, large corporation, but also SMEs, RTO spin-off, and other startups that are not coming out of the RTO themselves. And we do this, or RTOs do this through different phase with different kind of funding. Of course, there's a core public funding that is needed to develop skills and to invest in infrastructure. Um, then there is a technology development phase that is more of a mixed funding with public and private funding combined, competitive calls. Typically EU programs are supporting this technology development. And then the last phase is to apply the knowledge, to transfer the technology to the industry, and that could happen in a more private funding way through bilateral collaboration, direct contracts with industry. Then I have a few slides about the three RTOs I'm speaking on behalf. Of course, you know probably all of them, so it's only one or two slides on CEA, Fraunhofer, and IMEC. As being CEA, I will start with CEA-Leti. So next slide, CEA-Leti is located in Grenoble. It's almost 60 years old. It's been created in 1967. And as you can see, you have all the features that I listed before for an RTO. We have 2,000 research engineers. We have technology platform, research infrastructure with more than 11,000 square meter clean room space, a number of patents, something like 300 patents a year, new patents every year, and 40% of these patents are under license. A number of partnership with industry and a budget that is a bit less than 500 million euro. A good proportion of this budget coming from R&D contracts, meaning contracts with industry or public competitive money like grants. And CEA-Leti, as you can see in next slide, is in Grenoble, working in a whole in a full ecosystem with companies, French, European, and companies from outside Europe, specialized in the field of semiconductor or using semiconductor technology. And that's very important also that most of the RTOs, if not all the RTOs, are working closely with an ecosystem or in an ecosystem of companies, because that's the reason why RTO exists, is to develop technology and transfer to industry. The next one you see is, of course, Fraunhofer. I believe everybody knows Fraunhofer, which is one of the biggest, if not probably the biggest research organization in Europe, founded in 1949, 30,000 employees, 76 institutes all over the country in Germany. And Fraunhofer organization is involved in many topics. Among them is microelectronics, but also energy, health, materials, production. And in the next slide, you can see that there is a specific organization within Fraunhofer for microelectronic through the FMD, the Fraunhofer Microelectronic Group, which is constituted by 13 institutes from Fraunhofer and Leibniz. And there again, you see we have all the metrics of RTOs with a massive infrastructure, almost 20,000 square meter clean rooms, 4,500 people, a huge investment and continuous public funding for infrastructure and development. And that's really some metrics that you can find in all RTOs involved in the semiconductor technology development. And the last one, IMEC, you will see next slide. Of course, everybody knows IMEC 2, which is actually celebrating the 40 years this year. So it's been created in 1984 with more than 5,000 experts and scientists. Also boasting unique infrastructure with more than 12,000 square meter clean rooms. Currently building new facilities like CEA-Leti and Fraunhofer do, and working with a full ecosystem of more than 600 partners along the whole value chain of semiconductor. So working with foundries, fabless, material and equipment manufacturers, as well as design house. Operation of clean rooms are 24 hours, 7 days a week. Like continuous operation is quite usual for RTOs with infrastructure of this scale. And next slide, you see that IMEC is working as this is a vision also of ERTO, working to develop disruptive innovation to address today's challenge: climate change, mobility, healthcare, sustainable food. That's really also in the vision of ERTO. Then I will provide a few examples of impact and achievement. Of course, there are a lot of examples that I could take. I chose to present some EU projects because a lot of interaction between RTOs and industry within the IPCEI or also merged with EU project. This is a slide courtesy of Soitec presenting a number of projects that concern the work stream Think, Communicate, and Act. I could also have presented some other projects within the Sense work stream, especially with ST Micro. And you see that over the past 10 years, there's been a huge number of projects for SOI development, for telecommunication, for power electronics, and now more and more for sustainability. Next slide is also a number of examples from Fraunhofer that has been involved in telecommunication, 5G, terahertz technology, 6G, new computing technology like quantum computing, neuromorphic computing, also involved in the European Processor Initiative, and more, as I said before, some sustainability projects and and security applications. Just to say that there is a big number of European projects that is supporting this interaction between RTOs and industry. And the next one is also showing a number of projects in which IMEC has been involved under the Excel GU and then KDT and Chip GU to develop advanced CMOS node up to beyond 2 nanometer with the 14 angstrom and 10 angstrom exploration programs. So all in all, it's just to show that a lot of projects have been achieved through EU programs and thanks to IPCEI program, and we are continuing to develop this program. And I just choose one. The next slide is a Genesis project that stands for Generate in Europe, a Sustainable Industry for Semiconductors. It's only a proposal so far. It's been submitted, so it's currently under evaluation, and we have very high hopes that we can implement this project, but we are still waiting for the result of the evaluation. This is coordinated by CEA-Leti, but as you can see, this project is gathering 63 partners from 12 countries. It's a topic that is a growing concern for all the industry and the research organization to reduce IC manufacturing footprint. And what is interesting in this project, as very often it is a case in the project, is that we can involve the whole value chain. I mean, of course, semiconductor companies, but also equipment, materials, chemical companies, and also gas and water monitoring and treatment companies, recycling companies, and research is both academic research and RTOs all together with university and RTOs. And that's very important project for a very important topic that is there again of growing concern in EU and everywhere in the world. And the next slide shows what is going to be maybe a new possibility of interaction between RTOs and industry based on the pilot line. So we show this as proposal for pilot line. I mean, 4 of them, the nano IC, FAMES, APEX, and wideband gap pilot line, are currently under negotiation with the European Commission. A number of agreements have already been signed. We are still working on the last agreements to be at full speed in implementing this project. And the 5th project, PIX Europe, is, let's say, there's a second wave of calls for pilot line, and is not selected yet. It's been submitted a few weeks back. It's led by ICFO in Spain. It's a pilot line for photonic integrated circuits, and we expect to have the results soon. So then next slide, I will conclude and try the timing. Just 2 slides. One slide, I'm sorry, that's an example for CEA-Leti, but I believe that can translate to more or less all RTOs. That was to show that we can work at different stage with actors along the value chain, the semiconductor value chain. I mean, we can work with academia, upstream research team on upstream research project. We can work with equipment and material suppliers to develop a new process or new materials. Or work with company to mature the technology in recurrent lot mode, de-risk some technology and support industrial transfer to manufacturers. And of course, along the way, at different stage, we can also work with startup to mature the technology and develop technology and de-risk the technology for them. That's really what all RTOs are doing. The RTO core activity is between technology readiness level 2 and 6, and supporting the development of this technology to make it, let's say, ready for industrialization. So as a conclusion, I would say that, in my view, of course, RTO have a crucial role in this range of TRLs, mid-level TRL between 2 and 6. What is interesting is that there are no real similar player in US or Asia, which does not prevent them from being very good, of course. Everybody knows the power of the companies in US or Asia in the semiconductor industry, but the innovation is organized differently. How to collaborate with RTOs? I mean, you're probably familiar with most of the ways to collaborate with RTOs. All of them are developing bilateral specific collaboration programs or affiliate programs where several companies can join together to invest in a topic of interest, of common interest. EU project, we have all RTOs have a long practice of building, of being part of consortium for Horizon Europe or Excel, ENIAC, KDT, and now CHIPS project. And pilot lines is going to be maybe a new way of collaboration. We have to implement open access mechanism in these pilot lines, so it's only starting. As I said, we're still negotiating the agreements, but we will be back very soon, I believe, to explain what kind of open access mechanism we have implemented. And we believe that the value for companies is to de-risk the technology, to get leverage the specific expertise of RTO that can assemble various expertise to focus on a dedicated program, and maybe also to use the flexibility of RTO infrastructure, which is probably a little more versatile that a fully optimized production line. And you have a number of RTOs in Europe that have very good capability, clean rooms, and that can do a lot of things in these clean rooms that are maybe not as easy to do in a production environment. And the conclusion would be that We all know that there are currently a lot of discussion to prepare the next financial framework program and the FP10, and we really need technology research to be recognized, valued, and supported, and to keep the strengths that we have in Europe. Thank you very much.
Thank you so much, Bruno. This was very interesting to share those insights from a large RTO point of view. I invite everyone again to use the Q&A tool to ask your questions you might have for Bruno. And otherwise, we will now move on to our second speaker. Lorenza Ferrario from FBK. Lorenza will be exploring FBK's role within the ITFAB consortium, and she will also explain how RTOs can support SMEs through innovation. So Lorenza, please go ahead.
So thank you for the introduction and the opportunity, and to CNR, which co-prepared this presentation. So next, please. In this presentation, I will say some word about an Italian network, which include the two use cases that I will go then to details, and I will then conclude with a sort of toolbox that we built in the past to be a functioning RTO in the Italian panorama. Next, please. So ITFAB is an Italian cluster of public RTOs, and each one has microelectronic facilities, and we decided to stay together to become the Italian node of European networks and distributed infrastructures like Euronanolab and Riana, which help us support not only academy but also the companies to access this very high-tech infrastructure. And so let's say that the unity is a strength, and we decided to cooperate for this reason. Next, please. The Fondazione Bruno Kessler is one of the two use cases, and it is a public non-profit research institution which is operating since more than 60 years in Italy, and works in several scientific and humanities areas of research. It is organized in research centers, each one focalized on one research topic, like artificial intelligence, culture, or sensor and devices, or energy. And the mission is to be excellent in science and technology, with particular emphasis on interdisciplinary approaches. And I like to underline that sentence that I reported, that is from the founding act of the Fondazione, which stressed the fact that we have in our mission the technology transfer. So we can really say that the Fondazione is an RTO, since it must cooperate with companies to exploit the technology and to arrive to the market. Next, please. The Sensor and Devices Center of the Fondazione has a well-organized micro and nano facility, including several clean rooms of different ISO classes, testing capabilities, integration, and characterization. And this facility allows us to work, let's say, from the blank wafer to a complete demonstrator inside our laboratories, so that we say that we cover the whole value chain from the design of a new sensor to its to the possibility to test it in the environment and in the application area. Next, please. What is our topics? What are our main topics? We are highly specialized in silicon sensors, and in this area we work on radiation sensor, MEMS, and photonics and quantum devices, with high-skilled know-how, not only in the fabrication, but also in the design and simulation, with the possibility to also design CMOS-like architecture. And all of these sensors are then developed in the facility. Next, please. The other use case is the CNR, the Italian National Research Council. It is the biggest public research institution in Italy, and it is directly coordinated with the Italian Research Ministry. It was founded in 1923 and has, as you see, several thousand of employees, more than 90 different research institutes, and also the CNR is active in different research areas, spanning from technology to humanities and social sciences. Among these institutions, we have the CNR EMM, the Institute for Microelectronic and Microsystem, which is focused on microelectronic research, and that is an associated partner in the IPCEI Microelectronic and Communication Initiative. Next one, the EMM CNR has its headquarters in south of Italy, in Catania, but other sites spread in different Italian cities, and has a quite huge research staff with more than 170 people and huge technical support staff, and hosts more than 100 PhD students and postdoc. Next. Okay, in the main headquarters, CNR EMM has this big facility and the state-of-the-art facility, the Beyond Nano facility. It was funded with more than 70 million euro and allowed to develop devices and working on 200 millimeter wafers. And there are three main activity areas: power and radio frequency electronics, advanced photonics, materials, and device characterization. For each of these areas, there are dedicated laboratories collaborating with companies and also with the companies developing equipment. Next. Both Fondazione Bruno Kessler and CNR IMM are actively operating to bridge the gap from, let's say, research to companies, and, for example, from new materials to devices and application in microelectronics. How do we implement this? This is in the next slide. First of all, we applied to the IPCEI Microelectronic and Communication project, which directly want to strengthen the European industry. And FBK was already in the IPCEI Microelectronic, so the previous project, where we started to work on the 3D integration of silicon on silicon systems, and we are now closing the project and already very close to first industrial deployment of the first demonstrator together with some companies. In the new IPCEI, we will contribute to the SENSE work stream, widening our technology to silicon carbide, germanium on silicon, and to widen the integration capabilities to hybrid integration. So to be able to contribute to future, for example, future electronic vehicles or harsh environment application or communication application. Next, please. where CNR EMM is contributing to IPCEI microelectronic and communication with the three main area research activities. Two are in the workstream ACT and one in the workstream SENSE. In the first case, they will be delivered transistor in silicon carbide and gallium nitride with optimized contact, but also photovoltaic system, photovoltaic bifacial system and cells suited to be integrated in buildings where appropriate design and implementation will optimize the performances also in case of shadow or partial shadow of the system. The SENSE workstream will see the development of devices and materials, let's say, green compatible, green oriented, and so, for example, a system based on biodegradable materials. Next, please. Are we really working with companies? Yes, we do, and here are highlighted some of the companies that FBK is starting to cooperate thanks to the IPCEI project, but also many other in Italy and outside Italy, where we try to collaborate in research activities or directly to try to support the increasing of the tier L of ideas for these companies. Next one, please. Thanks. So what is our, let's say, working style? How do we implement at FBK the concept of RTO? For us, to be an RTO is to try to support companies to test a niche market or to test a big market, but with the niche test and small volume production. So what we try to do is to customize technology, so to bring it to a pre-competitive level and to allow all companies or agencies to test on the field, so with high tier L. And this is already experienced in our laboratories on different class of devices that we call technology platform. For us, it is a way to be very fast then to move from the first request to the final stabilized process, because this is the real challenge, is to be able to arrive to a process flow, so to fabrication process flow of sensor that has a controlled yield and controlled features. Next slide, please. A more detailed, a specific example taken from the previous list is that of a silicon photomultiplier. Silicon photomultiplier can be used in a large number of applications, each one using, let's say, a different light spectrum part. The design for each of these different spectrum parts can be similar, but you need to customize, for example, the optical features to adapt the process flow to the different application. But once you have the knowledge of the type of sensor, and you try to also design an industrial process flow that is easy to be replicated, that it is not expensive, that is fast, then you can adapt it to different application. Not only, you can also try to modify it for integration purposes, and so to recombine the sequence of steps that you need to fabricate it, to integrate then the sensor already with the electronic during the fabrication itself. So it's a way to become real good in technology and not only in research. Next, please. CNR EMM working with companies is shown in this slide. And as you have seen before, the different sites available in Italy have a slightly different specialization in microelectronic activities, and according to this, they collaborate with different companies. And so Catania is working on, especially on power electronic and green application with the Enel, ST Microelectronic and LPA. Agrate more on materials and memories with the ST Microelectronics. Lecce has connection with Leonardo, and Bologna, especially on green area research, where Roma has 2 sites collaborating with Nanomicrofab and Leonardo. Next, please. Working with companies collaboration. In the previous presentation, we have already seen a very good description of what is an RTO and features and how they can support companies. And here is the list of what the Italian RTOs I'm presenting are really trying to operate. So we join RD projects, but we can also support companies, because in our organization we have dedicated support services that can address choices. Sorry. And I previously mentioned Rihanna. Being part of this international infrastructure is also important, because companies, not just academic, are favored in finding facilities where they can ask support or implement their ideas. So also offering in this organization is part of improving the networking and the support. Then something that is more specific, like what I show, being able to do a small-scale service or a small-scale production, so not just a good proof of concept, but also a replicable process flow, and the possibility to have a small number of demonstrators to test the idea even in the market. Also, the training is a good way of collaborate, because you know that today one of the most precious things is having good skills and well-trained people, and the possibility to train people in state-of-the-art laboratories is a great opportunity, not just for students, but also for researchers and also for company staff. Finally, and it's probably the most complex way to collaborate, is open the facility to external users, also to companies that have the possibility to directly use, say, tools the capability according to a well-organized access policy. It is important for, say, the Europe in general, but also for the sustainability of the institution, because the investment that you have to do to stay at the, say, edge of the excellence, to stay excellent, are very huge. And more you open your facility, more you have possibility also to balance the investment being funded, and so improve your sustainability, long-term sustainability. Next, please. Next one, okay. This is about the TRL system. So typically, when you talk about rising the TRL, you think about moving, okay, from a research idea to a product. You can do this in several ways. It is very often a matter of choosing the right, say, investment. Because as you see in blue is where you invest to remain a good research partner, to good, excellent research. In red is what you really have to do in your organization to become a technology transfer partner. Okay, so to do a good research, even applied research together with company, you probably need very good research staff, state-of-the-art equipment, even single equipment, because you have to test this or that part of your device or of your process. But when you start to think to technology transfer, you have to change your organization to consider not just research, but also technology. And so invest in training for science, but also technological approach. And then to start to think about yield increase, and probably you need to adapt the quality management in your organization, and maybe to invest for having the ISO certification. And then to see, okay, I don't only do this part of the sample of the process, I want to be able to do a complete object. And this means to have not just few equipment, but probably a complex laboratory, to invest in maintenance, to have a uptime very high. And finally, to start to reason how to transfer your, say, good process to large production, because it's not probably feasible in your laboratory. And so you have to have people trained to dialogue with companies to understand how to transfer your process flow from your pilot line to a big foundry. Okay, and just to repeat, these choices have been done in FBK and CNR, and the organization is today highly oriented to supporting companies in this way. Next, please. Next slide, please. Okay. Arriving to this level is a long, say, path, and here some of the lessons learned in the years. So first of all, if you want to support external user, okay, and not just your internal research staff, you must understand what are they need, what are they target, that are not the fantastic device, but is a system. And so you must try to understand what are cost constraint, time constraint, and also TRL required to answer to the request of your customer. And so, for example, understand if R&D is required, or if you have already some technology ready to be delivered, to have a clear temporal planning. So it's important, for example, to have a stable staff, because sometimes in the academy or in the research institution, you have a high turnover that is not very good in this sense. You should have competencies to manage the intellectual properties and the confidentiality, also policy inside the organization. Access policy. Before I said it's good to open facilities and the pilot lines to the external customer, but you have to have policies to manage safety, or this IP, and so on. You have to guarantee long-term investment, because what is really important is a controlled uptime, and this is possible if you have investment in equipment, but also to retain skilled staff in your institution. Next, please. Okay, I think it's all. Thank you for your attention.
Thank you so much, Lorenza, for these additional insights. So now that we have had both from large RTOs and from smaller RTOs insights on how they can actually contribute to the whole innovation process within the semiconductor industry, and of course also in the telecommunication industry, it's now time to move on to the questions. So I invite all participants to use the Q&A tool, or if you don't find this tool, to post your questions in the chat of Teams. Maybe one question to start with of interest for all of you. We did see that RTOs focus also on this expertise and providing the necessary skills. So how exactly can we imagine the role that RTOs can play in education and training of young researchers and engineers? For the discussion, I also invite those who helped preparing the presentations to answer in the chat. And maybe from CNR side, Salvatore, you can give an answer to this question.
Hello, thank you for inviting me in this very important webinar. Okay, yeah, the question has more or less been answered by the previous speakers, but just to clarify, the point is that the education, clearly the universities provide in many cases excellent theoretical background, but the RTOs can add an important aspect, which is some real experience, especially in terms of contacts with industry people. This means that one can teach to these young talents the attention to products and the state-of-art industry. Also, the needs of time to market has already been underlined before. The problem of cost of the components and so on. And this is done, let's say, in a protected environment without the pressure of being in a company, because usually this is done within a PhD course. And on the other hand, so this is good, let's say, for the young talents, but I think it's also good for the companies because the companies have the occasion to find good young talent, and in many cases these can be directly hired by the companies. So I would say that the RTOs can play a very important role also in the education value chain.
Thank you so much. There may be one question for Bruno. Within the larger RTOs, you mentioned also the RTO network. Is there a way for those RTOs who are not yet part of this network to find them, or are there any specific events where they can go to meet other RTOs?
Yeah, sorry, I need to put the speaker. Yeah, there are a number of events that are organized by each RTO. I believe the association has its own webinar and reunion. That's maybe a way to embrace all the RTOs in Europe at once. And then each RTO has its annual review, annual forum. I mean, Fraunhofer, IMEC, CEA-Leti. I mean, most RTO that I know of have a regular seminar or annual review, which is a good occasion to learn more about the programs, to meet the people, and to have an in-depth discussion. There's a number of events also organized at the EU level. I believe some may know that the CHIPS GU will have its annual event in Ghent in December. There is Semicon next week in Munich. Most RTOs will be there present. We will have a booth to meet companies and research partners to discuss about the pilot line. So I believe the four first pilot line have been showing led by IMEC, Fraunhofer, CNR, and CEA-Leti. Will be present on the CHIPS GU booth next week in Semicon to talk about the pilot line. So I believe there's a lot of occasion to meet and to meet us. And we will even have more occasion as in the frame of these pilot lines projects, who are very big projects. We will multiply the occasions of reaching out to companies and research partners everywhere in Europe, because that's also one of the big challenge of this pilot line, is to open up and to diversify the types of collaboration that we have today, and maybe go and talk also to research actors and companies who are not used to talk to.
And of course, let's not forget about the IPCEI MECT networking events in Paris, the 27th of November, where some of you will also be present. And I think this would be a great occasion to discuss in more detail what could be the role of the different partners already present in this program. There's another question which arrived, which is you already touched upon RTO's role in the two IPCEI programs, but maybe a little more general. How do you see the role of IPCEI initiatives in addressing obvious bottlenecks and challenges within the European semiconductor industry, and which role can collaborations between RTOs and companies, as mentioned today, play? So maybe Lorenza, on the role of RTOs within IPCEI on addressing these bottlenecks, how do you see this?
Yeah, the role that we can play is to support, especially not only small companies, but even especially them, to have a place where to try to start activity with a high value without having to invest in really expensive facilities. Because one point in the microelectronics is that if you want to start activities in that field, you must invest tens of billions before being able to have a production. Where with RTOs within the pilot, you can say, okay, I will try my idea, I will start with them, and I will also take advantage of their previous knowledge, okay, to enter the market. These things, I think, is where we can really support and try to reduce the bottlenecks.
Thank you so much. And Bruno, on the role the collaborations between RTOs and companies can play, especially in these challenges within the European semiconductor. What is your vision on this?
I believe we have a good track record of collaboration within IPCEI programs and mixed with EU programs, and we should keep that. I mean, today, I'm not sure the role of RTOs is going to change. I mean, it's already quite well defined how we work with companies and how we can, as I showed, support technology development and de-risk technology and mature the technology. But I believe what we need to be careful about is to try and keep this. And you know, there's a lot of discussion on the future of EU programs. IPCEI is part of this discussion, and we should try and be very careful about the future orientation of this program and try and keep the good thing that we have today.
So I think the answer is quite obvious. So, but I would like to have both feedback on, okay, what do you feel that the IPCEI initiative will really contribute? I think, I mean, from my side, I would say this is really going in the right direction, and we should definitely continue to have these kind of initiatives. But I would like to hear it from both of you as well.
Well, my hope is that thanks to IPCEI program, RTOs and companies will further improve their collaboration, because for sure taking the right decision is much better if we do all together, each one with its role, okay? But the challenge that we have is really big, and we must try to go all of us in the same direction, okay? So it's not just a technical challenge, it's really a philosophical challenge for European players.
And Bruno?
Yeah, I think, I don't know exactly what you expect as an answer. I mean, I believe we're quite involved in IPCEI programs already, and we would like to keep it keep going like that. I mean, we know it's a very good let's say program to involve industry and RTOs all together, then I don't see any major change from our standpoint, because we already well connected with the French authorities and companies, and we feel that we play our role in this program.
I fully agree with this, and I think with these positive words we can end the webinar of today. But of course, not without thanking both of you, Bruno and Lorenza, for being speaker today, and of course also thanks to your collaborators in the preparation of the slides and their presence for the Q&A session. As a reminder, a replay of today's webinar will be available soon on our YouTube channel, so you feel free to revisit the discussions or share the webinar with any colleagues who might be interested to hear more about the role of RTOs in the semiconductor industry. And as we look ahead, we are also pleased to announce that our next webinar is planned for around April 2025, and we encourage every one of you to follow our LinkedIn page and visit our website, as you can see on the screen right now, for the latest updates and upcoming events and initiatives. And of course, we always invite everyone to also suggest their own events linked to the semiconductor industry, linked to the IPCEI program, and we are very excited to meet all, if not at least many of you, in person at our Sustainability Forum, the networking event organized in Paris on the 27th of November. This would be a great opportunity to connect, to share your ideas, and to continue the important discussions we started today on new collaborations, existing collaborations, and strengthening the field altogether, making Europe a strong actor in this field. So thank you once again for joining us today, and we look forward to seeing you in one of our next events. And Bruno and Lorenza, thank you again also for being a speaker today. Wishing you all a very nice end of the day.
Thank you. Bye.
Thank you very much. Bye.
Thank you very much. Bye-bye.